But in the case of Steam, in the case of GeForce Now, it only takes about a minute. And so why don't we go ahead and launch a game. Now that it's installed, let's launch it. And this game doesn't run on a Mac, and this game runs very poorly on integrated graphics, but yet we're going to see it working here in its full fidelity. And one of the things that's really cool is that it just works exactly the way you would expect an app to work on a computer. It's completely seamless to you. You pretty much forget that it's even in the cloud. And video games are complicated in the sense that the game is always being patched, there's always digital download content, the drivers have to be enhanced all the time, and we can do that all behind your back, update it all the time, keep your computer always fresh. And there it is, Tomb Raider, running on GeForce Now, over the cloud. A click away. Video games for the other billion PC users. Okay, thank you. So GeForce Now will be available in March for the early users. It's coming very, very soon. We're putting the final touches in there. And it'll be available for $25 for 20 hours of play. It's basically a GeForce gaming PC on demand. GeForce gaming PC on demand. There'll be several grades of performance that are available to you. The higher performance grades, you'll have fewer hours for each 25 hours of play, for every $25 of credits. Okay, so GeForce Now. Incredible value for somebody who doesn't have the ability to access a gaming PC, somebody who hasn't taken the effort to build a gaming PC, or who's somebody who just plays infrequently but would love to be able to enjoy a video game from time to time. GeForce Now. Thank you. Why don't we take a look at television now? A year and a half ago, we announced our partnership with Google to build the world's first Android TV. Our vision was that just as smartphones has revolutionized the way we do mobile computing and communicate, that smart TVs would also revolutionize the way we enjoy entertainment at home. That with a powerful computer connected to a cloud store, able to run applications, that we would be able to realize this new revolution in how we enjoy content at home. We call that Shield, and it was the world's first Android TV console. And it was built by Nvidia, of course. You would expect the performance to be incredibly good. Users all over the world have been absolutely delighted by it. We've continued to refine it and support it and enhance it. The number of applications is growing. The performance keeps getting richer. Today we're announcing a major upgrade to Shield. Ladies and gentlemen, the new Shield. The new Shield is amazing on so many different fronts. But the most important thing, the first thing that you get hit by, is that it's the world's first entertainment platform that is full 4K and HDR. Netflix and Amazon worked closely with our engineers, and we're announcing that Shield will be the first entertainment platform that is able to enjoy Netflix and Amazon's library of content in 4K HDR. We have 4K services from YouTube, we have 4K services from Google Play. We know that they're all tens of millions of PC gamers around the world, and they have GeForce Gaming, and they would like to take that GeForce Gaming PC and connect their Steam service to our television. We worked with Valve, and we're making available for the very first time a Steam app on Android Play, a Steam app on Shield that connects to your PC, and you can enjoy 4K HDR gaming on your TV while it's playing on your PC. And if you would like to have access to even more games, we now have 1,000 games in the Nvidia Shield game store. This is just an incredible amount of content. 4K HDR, You could stream content from your PC through Valve Steam, and you could, of course, enjoy great games on the Nvidia store. 4K HDR. But we didn't stop there. The two most popular consumer electronics platforms today. One is the smart television, products like Apple TV and the Shield. But the other is the Amazon Echo. It brings AI into your home, allows you to communicate naturally with an AI assistant. We thought, why have two devices when you can have one? And so we decided to work with Google to create the world's first Android TV with the Google Assistant. Now your television, which is the largest screen in your house, can be controlled through natural language. You can control your content, you can access your content, seek content, find content, play it, stop it, fast forward it, look for photographs, ask it questions. You could even control your home. But we didn't stop there. We felt that if you had a Google Assistant and you had an AI agent in your home, it seems to me that you would want to have it all over your home. That you shouldn't want to have to lean over to the coffee table and yell commands at it all the time. Wouldn't it be nice if your AI was completely ambient and you're just talking naturally? And there are all kinds of many spots around the house where you could ask your AI agent to help you do things. Maybe call an Uber, maybe make coffee, maybe turn on some music, ask it about the weather. So we decided to create a peripheral for Shield. And this is an AI microphone, and this AI mic could be anywhere in the house. And there's this little tiny thing I'm about to show you to you now, announcing the Nvidia Spot.
Hi, how can I help?
This little tiny device plugs directly into the wall. And because the computing is done on Shield, we can have a whole bunch of these all over the house. And this little tiny microphone has far field processing, has echo cancellation, so it picks up your speech relatively naturally, 20 feet away. And if you have multiple of these devices in a large room, it also does triangulation of where you are using beamforming. It figures out, based on the different arrival times of your voice, subtle arrival times of your voice, and it's able to triangulate where you are in the room, who's talking, and with beamforming, focus the energy of the beam, of the antennas, to the person who's actually talking. You could have all of these devices all over the house, and they all go through one Shield over Wi-Fi. Incredible, incredible capability. Brand new Nvidia Spot. We made a short little video to help you understand how we imagine people using the Google Assistant and the Nvidia Spot in your home. Let's play it.
Okay, Google, start my day.
Okay, I'm turning up your thermostat and brewing you a fresh pot of coffee.
Okay, Google, play the news.
Pending home sales dropped in November to the lowest level in 10 years.
Okay, Google, I'm leaving.
Shutting down your house. Have a great day.
Okay, Google, show me some popular TV shows.
Just drama.
Only recent ones. Play trailer from Stranger Things.
Hey, that looks like your grandma's house.
Kind of. Okay, Google, show pictures of Grandma Mary's house.
See what I say?
Yeah, you're right.
Do you want to watch it?
Yeah, let's watch it.
Okay, Google, play Stranger Things on Netflix.
What do you guys think? The combination of a smart TV and an AI assistant in your home that is completely ambient completely changes how we interact with our house. I think in the future, our house is going to become an AI. And increasingly, the vision of Jarvis is going to be realized. And whereas Mark Zuckerberg at Facebook has incredible programming skills, and he could take his here to build Jarvis for his home, I've decided that we should build it for all of you. And so today with Shield, with the new Shield, with the Nvidia Spot, the Google Assistant, and the integration with the Smart Things Hub that connects to hundreds of consumer electronics devices, smart plugs, coffee makers, garage doors, locks, thermostats, smart cameras. We can now integrate all of those consumer electronics devices and all of the exciting ones that we announced this year into the Shield experience, and all controlled by Google Assistant. So ladies and gentlemen, the brand new Shield for $199. The Nvidia Spot will be available as a separate peripheral, and we'll announce it in the coming months. The Nvidia Shield. Now let's talk about AI for transportation. As we all know, transportation is one of the largest industries in the world. There's 1 billion cars on the road. Just in a single day, 20 million ride shares are hailed on just Didi and Uber alone. There are 300 million trucks on the road carrying things to us so that we could live our lives. The infrastructure of society is made possible by all of these trucks, and they're carrying things over 1 trillion miles a year. There's 500,000 buses in just large cities alone, helping us with public transportation. This transportation industry is one of the largest industries in the world. It is also one of the most vital. Without it, society doesn't move forward. Without it, we don't have the fundamental infrastructure to live our lives. Everything we enjoy, everything we own, everything we eat and nourish our families with, all as a result of transportation. And yet, this is also one of the industries that has the largest waste. And the largest waste comes from human error. The fact of the matter is, these massive machines shouldn't be operated by humans, or they should be operated by humans with quite a substantial amount of assistance. The amount of waste that comes from accidents, whether it's damages or loss of lives, emergency room visits, insurance, measures in hundreds of billions of dollars a year. Over the course of a decade or two, the waste and the human suffering that comes from it is enormous. There's other forms of waste as well. Most of the cars that we enjoy are mostly parked. By and large, everywhere we look, there are parked cars. There are parked cars in beaches and parks. There are parked cars in cities. There are parked cars on campuses. By the way, this is the Nvidia campus. There are parked cars all over the streets, littered everywhere. Wouldn't it be amazing if we also reduced that waste? And how can we change the face of our community? How can we reinvent our lives? The amount of waste that we could help contribute to reduction, if we could somehow bring to bear autonomous vehicles, what is otherwise known as self-driving cars, would be absolutely amazing. This is the reason why we've decided almost a decade ago to start working on autonomous vehicles and to start developing the technology necessary for someday for your car to become essentially your most personal robot. And it is so intelligent that it's able to perform its function, enhance your mobility, keep people safe, while of course do it intelligently and keep people out of harm's way. The technology necessary to do so is incredibly hard until just very recently. GPU deep learning has made it possible for us to finally imagine realizing this vision in the next year. We can realize this vision right now. Now, when you think about self-driving cars, at some level, it's relatively easy. It's easy because we all do it. It's so easy that we can't even explain it. How do you explain to somebody on a sheet of paper that has never driven a car how to drive a car? Well, the reason for that is because intelligence that we've come very naturally with is incredibly hard for computers. And as I mentioned earlier, deep learning has made it possible for us to finally crack that nut. That with deep learning, we can now perceive the world, not just sense the world. Sensation is seeing, hearing, touching, those are senses. Perception is accumulating all of those senses and building a mental model of what it is that you're perceiving. We can now finally, with deep learning, perceive our environment surrounding the car. We can also reason about where the car is, where everything else is around the car, and where everything will be in the near future. We can predict, using artificial intelligence, where everything else around us and where we will be, so that we can decide whether the path that we're on or the new path that we're going to take is going to be safe. We also have the ability now, as I've shown you earlier, with the same with robotics, motor skills, and walking skills, that we could use the same technology to teach a car how to drive, just by watching us. By watching us, observing us, learning from us, a car could literally learn how to drive. That, supported by HD maps, which are maps in the cloud, another way of thinking about, in the context of intelligence, knowledge, a priori knowledge. We can now compare what we perceive with what we know to be true in the cloud and determine what to do. And meanwhile, you can never stop learning. The world is changing all the time. It seems every single week a new road is being beaten up or fixed, something is being added, lanes are being added, roads are being shifted. We have to continuously map, continuously relearn the environment. All of that requires AI computing. And it's one of the reasons why we dedicated ourselves to building a fundamental new computer that would go into a car that has the ability to do all of this deep learning processing and to do it at very high rates. We call it an AI car supercomputer. And our AI car supercomputer used to be multiple chips. And we're building a new one, it's called Xavier, that fits into a little tiny computer like this. This is what an AI supercomputer looks like for your future self-driving car. It's a little tiny computer like this, and it has sensor information that comes in, and CAN information controls the accelerator, the brakes, the steering, and all of the other things that you want to control inside the car. This runs a new operating system we call DriveWorks that takes multiple sensors in, fuses it, recognize and perceive, localize, reason, drive, and it does so while connecting to the HD map and comparing ourselves relative to the information that we get from the HD maps. Incredibly powerful. 8 high-end CPU cores inside this chip. 512 of our next generation GPU. It is ASIL D. The computer is ASIL D. The chip is ASIL C. It is the ASIL automotive safety integrity level. The quality level, the reliability level of this computer is bar none. And then lastly, we do all of that. The performance of a high-end gaming PC shrunk into a little tiny chip, 30 tera operations, trillion operations in just 30 watts. Little tiny computer. We can chain a whole bunch of these together depending on the application, and this will be the future of our self-driving car strategy. Let me show you now what our AI car computer can do. We created a car called BB-8 And it's an AI car, and it runs everything that I just described. This computer, this brand new operating system, and a whole bunch of AI networks. Let's roll it, please.
Disengage autopilot.
BB-8 is running on the East Coast, is running on the West Coast, and it's just incredibly fun watching BB-8 zipping around. Incredible. Whoa, whoa. So the Nvidia BB-8 AI car. So our vision is that these cars running all of the AI networks that I just described, connected to HD clouds, should be able to drive from address to address in a very large part of the world. However, there are always places where the confidence of the AI, the confidence of the car, is not high enough to drive by itself. But because it knows where it's going to go, it knows the path. It could determine its confidence level in different parts of the path. And it could tell you which part you should drive yourself where it has low confidence in supporting. We believe that the car is going to be an AI car for driving. But we believe the car itself should also be an AI co-pilot. So ladies and gentlemen, today we're announcing a new capability on the Nvidia AI car computer. It's called the AI co-pilot, and it basically works like this. Remember, the car has sensors all around it. It's got cameras, it's got radars, it's got lidars, so it has surround perception. The car also has cameras and speakers inside the car. And so it has internal car perception. It is aware of its surroundings. It's aware of the state of the driver. It's aware of the state of the passenger. And just as the Nvidia Spot gives you an array of speakers and microphones, there's an array of speakers and microphones inside the car. And so this car has incredible perception capability, if only the AI was running all the time. We believe that the AI